Hello and welcome to the next lesson in the SNAP course. So today we'll be covering some physics. So last time we just started adding sprites and stages to our platformer project, but this time we'll be actually starting with some code and some physics. So let's get started. Okay, so when things fall, they start speeding up, and it's kind of complicated in terms of its math. So rather than going over the math, we'll just try to implement the formulas. So today's going to be really short. We're just going to implement jumping. That's everything that we're going to do, and we're going to fix any bugs that arrive, because this can definitely bring bugs. So first of all, bugs are just problems with our code. So things that go wrong with our code. Then this will basically finish the motion part of the game. So we'll actually be able to move our sprite. Okay, so we're not going to be learning any specifically new concepts. We're just going to be practicing and trying out some code. Okay, so to start, we'll be needing a variable for velocity. So what velocity is how fast something moves in some direction. So a car might be going really fast along a highway. So the velocity is a number that says how fast it's going. So a car with a very big velocity, like maybe 60 miles per hour, is going very fast. A car with a very small velocity is going very slow. In 1 unit of time, an object moves by an amount equivalent to its velocity. So what that means is, let's say a car is going at 60 miles per hour. Then in 1 hour, the car will move 60 miles. Okay, so how can we actually implement this kind of stuff in Snap? So in Snap, first of all, up is positive and down is negative. So what that means is, remember when we talked about going to certain values in the coordinate plane or in the screen? If we say go to x equals 0, y equals 0, then we'll go to the center of the screen. But if we want to go up, we have to make y bigger, and we have to make it a positive number. So 2, 5, something like that, or 200. If we want it to be down, we have to make it something like a negative number. So like -2, -5, -200, etc. Okay, so also about velocity. Look at the image below. So if you look at the velocity of the ball, we can use these arrows to show how big the velocity is. So as you can see by the arrows, as the ball gets higher and higher, its velocity starts to change. It starts to get smaller and smaller. Its size gets smaller and smaller. And then it switches to the other direction and it gets bigger and bigger. So this seems kind of hard to implement, but it's actually not too hard. Because in reality, the amount that the velocity changes by is the same every time. So we'll see how we can implement that now. So create a new variable for the y velocity. The y velocity essentially represents how fast the sprite or character is moving in the y direction. So when the up arrow is pressed, if the player is touching the ground color, which is here it's white, then set the y velocity to 10. That way they're going to be moving up. That's what the y velocity of 10 means. 10 means that they're moving up at 10. That's how fast they're moving up. Now, in the forever loop that we had last time for movement, if the player is touching the ground color, which is white, set the y velocity to 0.5. Otherwise, if the player is not touching the ground color, change the y velocity by -0.5. So by doing this, every time the blob or the sprite or the character is going to get slower and slower and start moving or accelerating downwards. So that's how we'll simulate gravity. So this portal, you might notice that it looks kind of pixelated. And this was actually done using the set effect block, which is in the looks category. So you might want to check that out if you're interested in making a more pixelated portal. Also, just a side note, if you look at these colors here, they tell you how to do everything on here. Like if you want to create a new variable for the y velocity, go to the variables section. That's why it's dark orange. That light orange means go to the control block section and use the when up arrow is clicked. However, we'll see that this will actually bring a bug in the next slide. Also, if the player is touching the ground color, that's a sensing block, and so on. You can see everything. Okay, so the thing is, in real life, things don't get faster forever because air starts to push up on falling objects. So we need some kind of terminal velocity. So this is the fastest speed that a specific object will fall. So you can try incorporating this by using the following. If the size of the velocity is higher than a certain amount, just reset it to that amount. By doing this, it will reach a terminal velocity. So this will actually fix the glitch where the sprite suddenly falls deeper into a platform, because it falls deeper into a platform because it's not constantly checking if it's touching, it moves before it checks. So that will fix that glitch. Also, if you're done with that, make sure and fix any bugs and try to add more levels. So go through each stage and try playing it. The portal won't work, but you can just change the stage by going to the stages and clicking on the costumes that you want. Finally, if you're done with all of that, you can start the next thing, which is making one message for each level. And when each sprite receives the message for a certain level, it should reset to match that level. So make sure the sprites go to the beginning of the level and change the stage to that level. Okay, that's it for today, and we hope you enjoyed that lesson. You can try to fix all the bugs. That's the main part of today. And one other thing, remember how here we had this bug? Actually, not here, but here when we used when the up arrow is pressed, remember that this causes bugs sometimes because we, just the same way that we didn't use the when block, when this is blocks for movement right and left. So what you should actually do is in your forever loop, add an if statement. So if the up arrow is pressed, then do everything. So that would actually be a combination of the sensing blocks, the green, like the operator blocks, and the control blocks. Other than that, that's it for today. So we hope you enjoyed the lesson, and we'll see you next time.